We have another section where we're going to review some of the ideas of square roots. And again, it's moving very quickly. So this is all prerequisite stuff from Algebra 1. So make sure you're comfortable with this. So let's get started. One of the ideas that will be assumed in college algebra, Algebra 2 here, is that you remember how to rationalize a denominator. Now the idea is this: we don't want square roots in the denominator. It's basically like we're trying to divide this, but we can't. I'm not sure why this was originally started, like why we can't just leave this as a number. I'm not sure what the reasoning is, but it's pretty standard practice that we will rationalize it by getting it out of the denominator. Now watch the trick that they do. Rationalizing is this. I've just taken that square root that I didn't want down there and I've put it over top of itself. Now, if I multiply by the square root of 10 over the square root of 10, I haven't broken anything because that is just the number 1, right? Isn't that just 1? So I haven't broken any rules. Now, once I've created this, let's just multiply. You can multiply what's inside the houses, and you can get 2 square root of 30. And so, well, they've jumped a little too quickly here. So I've got 2 square root of 30 over 3 times the square root of 100. Oh, well, you can see, yeah. I'm going to show it like this. So the square root of 100 is a perfect square, which is 10, which is how they turn this into 3 times 10 is 30. Now, there's no more root in the denominator, so I have fixed this. Now, we have one last step. The 2 over 30, if that was just a regular fraction, we could simplify that by dividing them both by 2, and we got down to this. Now, this number and the original number, they're the same number, but what we've done is we've eliminated that root in the bottom. Pretty standard practice. Pretty standard practice for college algebra, Algebra 2. Okay, so let's do this again. We're trying to get rid of this square root of 2 in the denominator here. So the trick is just going to be to multiply the top and the bottom by the square root of 2. That's legal because that's just the number 1, right? So I can multiply inside the houses. So this is 12 square root of 6 over 2. Now 12 over 2 can reduce. That would just be, I can divide them both by 2, I'd get 6 square root of 6. Okay, now this is a more complicated one because everything on the bottom here, when there's a plus being added, this creates one giant number. And the trick, and again, I've got a whole lesson on this, so I won't go into the full detail of this, but the trick here is to multiply this by 1 minus the square root of 5. And it's the same trick, just to mention it, it's the same trick because to make a perfect square binomial, which is exactly what we're doing. So if we multiply this out, you have to FOIL it, just like you would FOIL this. So we're going to FOIL that out. And the beauty of it is, and you'll see in just a second, when I multiply this out, it's going to get rid of any roots on the bottom. So what I'm saying is the addition creates one giant number. And so we can't just multiply the bottom by the square root of 5. That will not work. We're going to have to do the conjugate, which is the same number, but with a minus instead of a plus. And this is going to follow the rules of a perfect square binomial, and it's going to work. It'll work it out. So let me show you, see if they've worked it, and I didn't. Okay, so I'm going to distribute these. So I've specifically chosen this as my value to multiply by. So if I go here times here, now square root of 5 times 1, square root of 5. Now, square root of 5 times itself is always just going to be 5, right? Now, there's a minus out front, so I would get this. Okay, now the reason we did this is because this will always create this opposite in the middle. Because of the alternate signs, it will always get rid of the middle, and the middle will be the root. So what I'll be left with is just 1 minus 5, or negative 4. Now, I'm going to do the same on the top. There times there is 4. You've got to distribute him, and there times there is going to be negative 4 square root of 5. So we haven't talked about multiplying them, but you multiply times the in front. So numbers outside multiply times the numbers outside. Now all of that is over negative 4. Okay. Let me show you. So there's a couple ways to think of this. You could think of this like the negative 4 can divide. Now there's a minus here, so there's two terms. The negative 4 would have to divide into both of those terms. Or you could think of it like this. Bring out a GCF. And now you could divide the 4's. And you'd be left with 1 minus the square root of 5 over that negative. But you could also make the negative, distribute it, and you could turn it into, it would flip it around. So if you just have minus outside of here, that's going to flip these signs the other way around. Let me do another one of these because I'm not sure if that was super clear. So we're going to multiply by the complex conjugate, which is the same thing on the bottom, but just a different sign. And you have to do this. Square root of 3 will not solve the problem. Okay, now we're going to distribute these. So on the bottom you'd FOIL, but here's what always happens. It turns out to be the square of the first one and the square of the back one, which is going to be just 3. And it always has a minus in the middle. Every time. FOIL it out, you're always going to find that. The middle's going to drop out. Square of the first one, square of the back, you got a minus in the middle. Now here we're going to distribute. I'd have 14 minus 7 square root of 3. Just send him to both. He's going to multiply by the 1 in the front there. Okay. Now all that is over 1, which doesn't really do anything, so it's 14 minus 7 square root of 3. Okay, so I guess we haven't seen yet some of the other kinds of roots, I guess. I guess we have not. So you don't have to just have square roots. You can have any kind of root. A fifth root means it takes 5 of the same number to bring it outside the house. A fourth root means it takes 4 of the same number to bring it out. You can have any possibility there. And so if I were doing negative, so first thing you got to be careful of, remember, at least at this point, we can't do a negative square root because there's no two numbers that multiply together to make a negative 4. That can't happen until we work with complex numbers that we'll see later. So I can't do this. So any even root, 2, maybe 4, 6, with a negative underneath cannot be done yet. However, odd ones can. There are 5 numbers that multiply times each other themselves to make negative 32. And that is negative 2. You could multiply 5 negative 2's to create negative 32. Now our second one here, first what we're going to do is we're going to multiply what's under the houses. Remember, we're allowed to do that. So if you multiply these together, you get this. Now, we're in the fourth root world. Is there a number times itself 4 times that makes 4096? It turns out there is. So it turns out it's 8. I guess I should say. So it turns out it's 8. So 8 times 8 times 8 times 8 would make that number. Now, if you didn't know and you wanted to do this, you could break 4096 down into its pieces. This is what I was talking about before. You could do that and just keep going, and you would find out that what you're going to get 4 of a kind. You're going to get enough 2's to bring out an 8. So that'd be a little bit too much to show you. But my point is the principle works on fourth roots just the same as it does on any other. Okay, so let's look at C here. Now I'm going to go, I would have checked to see if leaving it as a fraction would let me clean anything up, but nothing cleans up here. So then we could split it up into 2 individual cube roots this time. The principle's the same. Now 125 has a cube root. 5 times 5 times 5, so I can bring out a 5. 8 has a cube root, and x to the 6th. So, so think of it like this. If there were 6 x's under there and we're in the world of 3, it takes 3 of a kind in order to bring something out. So I could bring out 2 x's. Now there was a minus out front, he's just going to stay out front. Okay, now they went ahead and simplified this by seeing what could come out. The fourth root turns out to be, so 2 times 2 times 2, you could bring out a 16. So yeah, let me show you the 48 because I'm not sure that'll be clear. Okay, so here's 48 breaking down into its pieces. Now I'm in the world of 4, so it takes 4 of a kind to bring out a single number. So I can bring out a single 2, which is how they got down to 2, 4 through to 3. Now we saw before that if these are the same exact root, then it's just like variables or like terms. We can combine them and we'd get this. Okay, let's see what we've got here. 216 has a cube root, but I don't know what it is, so I'm going to do this. Okay, so I have broken this all the way down. Now, put those, I'm just putting, yeah. Okay, so I've broken this down. I've got just the primes in there. Now I know it was a negative 216, but I'm just going to work with 216 and know that I'm allowed to do that, and my answer will be a negative. So negatives under a cube root are okay. It's just going to be a negative. Okay, so I'm going to lasso groups of 3. So I can bring out a 2, and I can bring out a 3. Multiply them back together, I can bring out a 6. All right. Yeah, I kind of have a trick that I would probably do here. I'm not sure if that's what they have in mind. So let's just do 80. Okay, so if I break down 80, it's made up of 2 times 2 times 2 times 2 times 5. So 4 2's, because I'm in the world of 4, I could bring out a single 2. Now there's already a 3 out of there, so 3 times 2 would be 6. Now I've got square root of 5. Oops. Now again, there was another way here, but if these like function like variables, if I had an x on the top and an x on the bottom, I could cancel them. Well, I can do the same thing with the roots, and I can get down to 6. Again, I'm not sure if that's what they had in mind. Another way we could have done this is kind of move the 3 out front and put these guys underneath the same root and simplify it. You would have gotten there too. Okay. Oh boy, 9,000. Yeah, I think the way to go with this would be, oh man, 576, I don't know. I don't really want to try to break this one down, but okay, so this is made up of a whole bunch of 2's. Now, I didn't want to bring this in our house. I'm out of room here, but so 576 simplifies. I can bring out a 2 and another 2, and it's going to leave 9 behind. So that's going to bring out a 4. Got a 7 outside of there already. So 4 times 7 gets me 28. I'm left with a 9 inside. Now this one I saw. 9 times 1,000 is actually, so I've got to have my little cube root sign. 1,000 as a cube root, it's 10. So 10 can come out. 6 times 10, I've got 60. Cube root of 9 plus 28, cube root of 9. That one's pretty hard. Now these are the same kind of thing. That's like a variable, so I can combine them. Get 88 cube root of 9. Okay. Now, again, this is drinking from a fire hose if none of this is new to you, or if this is all new to you, but hopefully you remember some of this. So let's deal with the idea of exponents. A fractional exponent, and again, in the algebra videos, I can prove to you why this is, but a fractional exponent works like a root. So this is the same thing as the square root of x. or x to the 1/3 is the same thing as a cube root. So this denominator here is the root, the index of the root. This is called the index. So if I'm doing this, let's see what they've got for us. Here's what it would mean. It means I'm cube rooting and squaring. So anything on the top is still an exponent. Anything on the bottom is a root. Now it typically works better. I don't think I would have done it like that. But maybe it's necessary. You can do it. Well, I guess what they're just showing you is it can work either way. You could do the cube root first and then square it. Or you could give the square inside the root to the number and then cube root it. So it doesn't matter which way you go. They're telling us they're the same thing. I could cube root it and then square it, or I could square it and then cube root it. You'll get to the same place. So work down here is where they worked it. They did the cube root of 343 is 7, and then they squared it, and our number is 49. So if we were doing this, this means the square root of 9, and then we could take it to the 5th power. Well, the square root of 9 is 3, so we've got 3 to the 5th, which is a whole lot of 3's. I'm going to use my calculator. 243. Okay, now we can have that with variables as well. Yeah, this is just asking us to write it as in terms of the fractional exponent. We're not going to have to do anything here. Well, they brought it up to the top. I don't know. So here's what I would do. The exponent goes on top. Hold on. Let's start with this. This is confusing enough. So if I had this, the root is the denominator of the fraction of the exponent, and the 2 is the top. So the 7th root of a to the 2nd is a to the 2/7. Now, why this was confusing is that they also put it on the bottom. So I have 4 over a to the 2/7. Now, if you didn't want it on the bottom, you can move it to the top. And if you cross over that line, it changes the sign of the exponent. So it made it 4a to the negative 2/7. So anytime you cross over that fraction bar, you change the sign of the exponent. So usually we don't want a negative exponent, but we could if we wanted to bring it up. Since it crossed the line, it'd be negative 2/7. Okay, so I've got this x just kind of sitting out there, but the 5y is getting this treatment where it's being raised to the 9th power, but it's a square root. So, and it's all inside of there, so I'll have students leave off the parentheses. This is all happening to 5y. So 5y is all being taken to the 9th power and square rooted. Okay, now we've got some more crazy rules. Now here's why we might want to use these fractional exponents. Because combining them is much easier than working with the roots. So first of all, I'm just going to, let's see if we can trust them here. Yeah, this is good. They multiplied the numbers on the outside. So 5 times 2 times 3 gets me 30. Now we're going to multiply the x's. Now they have a like base, so we can add them. So I'm going to add 3/4 plus 1/5. Now I know this is crazy, but we can get a common denominator here. Now once I have a common denominator, I can combine them. So this is actually x is to the 19/20th power. I know that's strange. Okay, now this is true. I don't use this trick a whole lot, but if I had a fraction with a negative exponent, I could make it a positive exponent by just turning it upside down. So that's in some old Algebra 1 videos too. So if you want the reason here, wouldn't that be true? You could just move it to the bottom. So you could flip it over to bring it to the top. I didn't show that very well. It's a little more difficult to see with the fractional exponent. Yeah, I think going any farther trying to prove it isn't going to make it any easier. I'd have to think of a better example to make that more visible. But so if you have a negative exponent with a fraction inside, you can just turn it upside down. Now, if I'm taking the 1/2 power, I could give that half power to everybody. Well, or it's just one giant square root, and then I give the square root to each of them. Allows me to simplify it down to 3/4. Okay, so here I can just multiply my numbers. So I've got 8 times 14 gets me 112. Now, to put these together, I just need to add up those exponents because they're the same base. So I'm going to get a common denominator of 15 here. Okay, I get 23 over 15. So I can add these exponents up, and that is going to turn into 23 over 15. I know that's strange, but it's the same principle. We can just add them. You just have to remember, how do you add fractions like that? You got to get a common denominator. All right, once again, that's going fast. So I hope these make sense. All of these are super useful tools for college algebra, algebra 2. So try to make sure that you're up to speed on this.